Okay, we are about to start a fun chapter. I'd like to think statistics. I call it free marks, but we'll just do it together, and you'll see. Hopefully, you'll see how doable and fun it is. But stats is all about representing data, right? How do we get data? We investigate. What do we investigate? Whatever. Whether you want to investigate how many people aged 15 to 50 own iPhones and stuff like that, whatever it is that you would want to investigate, you would investigate it, and you would have to show us in terms of stats. Cool. So in stats, rather, we have two types of data. We have ungrouped data, we have grouped data. Okay, now what are we talking about? Let's start with ungrouped data. So ungrouped data is a data that shows the individual values. For example, when you are investigating maybe how many people own iPhones from age 15 to 60, you would go around, investigate this, and maybe collect ages zabantu abayi-20. Then you would find that maybe a 16-year-old owns an iPhone, a 20-year-old, a 22-year-old, a 21-year-old, a 23-year-old, and a 30-year-old, maybe one 50-year-old. How many are these? 1, 2, 3, 4, 5, 6, 7. Let's just do 7 for the sake of, so seven ages. They age from 16 to 50. And how many people are there? 1, 2, 3, 4, 5, 6, 7. This is ungrouped data. You can count the individual values. We call these discrete values, right? Since they're individual and distinct values that you can count. Is it making sense? They are countable like whole numbers. You can tell me how many people you were able to ask whether do you own an iPhone. How many people? 1, 2, 3, 4, 5, 6, 7, right? They are countable. All right, so let's look at the first point. Ungrouped data is a set of individual values or observations. The data is discrete since the values are distinct values. Distinct data is countable like whole numbers. 1, 2, 3, 4. An example would be the number of people at an event is discrete because you can count those individuals, right? So here, the number of people that we asked, hey, do you own an iPhone? We can count them. They are 7 people, right? And now for the sake of just knowing the difference between grouped and ungrouped data, we're not going to talk about grouped data right now, but later on. But how I would represent grouped data, I would say okay, now this is grouped data. You investigated, right? And you got the individual numbers of the people that you asked, their ages individually, and you can count here that 7 people, right? But now when you group it and write it in terms of an inequality, X represents the age, right? So the age of people were greater and equal to 16. There was, yes, 16, and then less than equal to 50. But from here, can you tell me how many people you asked? No, you can't, right? It's grouped data. You can only tell me Uguti they are age 16 to 50. Is it? I hope it's making sense. Okay, let's do our very first example. So this example says the American company Deloitte made a prediction that in 2014 the increase in number of smartphones being used worldwide would be the greatest for people over 55 years. In a survey conducted in a shopping mall during 2014, different people were approached and asked what type of phone they were using. The following table shows the ages of 30 people, right, between the ages 15 and 60 using smartphones. So these are people aged from 16, there are 17-year-olds, 25-year-olds, 28-year-olds, basically 16 to 56, right? And there are 30 people. That is what we are told. All right, so number A says draw a frequency table for this ungrouped discrete data. So a frequency table will show how many times different observations occur. So for example, 17 right here. How many 17-year-olds were approached during the conduction of this survey? 1, 2, 3, 4. So the frequency of 17-year-olds is 4. 4 people were asked. Is it making sense? And also one key thing to note when you were doing frequency is that you were told the number of people that were asked to share what type of phone that they were using. It's 30 people. So even when you do your frequency and you are adding up, but okay, there's 1 16-year-old, 4 17-year-olds, 2 18-year-olds, as you are doing it, the number of frequencies is zonke must equal 30 people, right? So we'll start with age 16, we'll go to 17, 18, 25, 27, will I have enough space? 28, 32, 34, 34, let's take it to the other side, 34, 46, 48. I'm so sorry, I have to carry on this side, you know, guys. 48, 48, 54, 54, 55, and 56, right? So I can already see 16, only one person. So when you do frequency, also do a tally mark for yourself. Now a tally mark will help you be more accurate, you know, just to make sure you are not missing anything. So you'll first say, okay, there's 1 16-year-old. Then when you do the frequency of it, you'll just write down the number 1, right? Then how many 17-year-olds? It's 1, 2, 3, 4. Then when you go write it down, it's 4, right? So doing it twice sort of like assures you, oh, see, you're not making a mistake. Yeah, but also just do a tally unless specified otherwise, ne? Because I'm seeing even in your textbook they are doing a tally mark, or tally marks rather, before they go to the final frequency, right? So how many 18-year-olds? There were 2 18-year-olds, and you write down frequency 2. 25-year-old, there were 2 25-year-olds, 1, 2, then you write down 2. For 27, I should have left more space between them. There's 1 27-year-old, you write down the number 1. For 28-year-olds, there were 1, 2, 3, 4, 5, 6 28-year-olds. So 1, 2, 3, 4. When you tally mark, okay, guys, so to 1, 2, 3, 4, and then this is 5, right? 6, so it's 6. So the slash, the big mark that cuts through the 4, also counts as one tally mark rather. It's 1, 2, 3, 4, 5, right? 32 is only 1 32-year-old. 34, there are 3 34-year-olds. 46, there are 2. 46, 48, there was 1 48-year-old. 54, 1 54-year-old. 55, 1 as well. And then for 56, there were 1 2 3 4 5. So it's 1 2 3 4, right? 5. Cool. So that's our frequency table complete. And just to make sure ukuthi asenza a mistake, they told us 30 people, right? So when you add 1 plus 4 plus 2 plus 2, plus 1 plus 6 plus 1 plus 3 plus 2 plus 1, plus 1 plus 1 plus 5, all of that should give you number of people equals to 30, right? So that should be a quick way for you to check during a test ukuthi you did not make a mistake when you were doing your frequency. If you get the total number of people that you were told were asked, then you did not make a mistake. Cool. Now we are going to represent the same set of information, still the same example, but now they asked us to represent it in terms of a stem and leaf plot, right? So with a stem and leaf, let's just look at a picture. I tried to draw a leaf and a stem as best as I could, but this would be the stem and this would be the leaf, right? So the stem would represent tens digits, and then the leaf would represent units. So what do you mean when you say tens digits and units? So let's look at maybe 25 and 28. What's the tens digit when it comes to 25 and 28? In this example, it's 20. They are in the 20s, right? And the units would be 5 and 8, right? So if we were doing a stem and leaf, we were told that a stem takes the tens digit rather takes the stem. So the stem would be this side, the leaf would be this side. So it would be 20, right? It's tens digit. But what are the units? There was 25 and there was 8, right? It's 25, 28. I hope it's making sense, or I hope it will make sense as we are doing it rather. So how many tens digits are there? We have 10 because there's 16, 17, 18. So we have 10 itself. Then we have a 20s, right? Then we have 30s, right? 40s and 50s, right? So now you fill in the units. Uyabo? I-units zeziphi? Zezi number zilaya in between i-tens. There were 16, right? So you'll put a 6 there. There was 17. One thing about leaves is that they have to have equal spaces between them. Uyabo? So it's 6, 7. There was another 7. There's another 7. There's another 7. 4 sevens, 1, 2, 3, 4, right? Then there's 8 and 8, and then we are done with the tens digits, right? And then we go on to the 20s. We had 5, 5, 7, 8, 8, 8, 8. How many 8s? So I just do it once. 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 8, and 8. I don't like how they're close. Okay, let me just fix it. Just make sure what's their actual equal spaces, not like literally, but oh, why am I increasing the number of 8s? There were 2 8s. 1, 1, 2, 3, 4, 5, 6. Right, then we go to the 30s. There was a 32, 4, 34, and another 34, and another 34. There were 3 34s, right? Then we go to the 40s. There was 46, 46, 8, 48, right? Then we go to the last, which is the 50s. There was 4, 54, 55, 56. How many 56s? 1, 2, 3, 4, 5. Therefore, you put 4, 5 6s. 1, 2, 3, 4, 5. And that is your stem and leaf diagram. These are the stems. 10s, 20s, 30s, 40s, 50s. These are the leaves. 54, 55, 56, 56, 56. I hope it makes sense. Now we'll move on to the bar graph. Now we are going to represent the same data using a frequency bar graph. So I'm just only going to teach you one option, but if you guys have questions about the first option in terms of how to draw the frequency bar graph, then you are free to ask me during class. But then this way would take longer, this way, where it would be a way of doing the ages individually. You see here, I just grouped the ages. I said 10 to 19. I'm just going to draw a bar graph here. 20 to 29, 30 to 39. I prefer this option. Or you could just do the ages individually, which is 16, 17, 18, 25, 27, 28. The individual will be a longer bar graph and a little bit more work. But if you work quickly enough, maybe you'll have enough time. I don't prefer the option. Just do 10 to 19, 20. Just group them in terms of E10s. Yeah, but I want 10 to 19, 20 to 29, 32. Okay, this is how we'll do it. We'll first start with 10 to 19. Then we'll go to and count the values that are between 10 and 19. Say 16, 17, 17, 17. It's 1, 2, 3, 4, 5, 6, 7. Right? Then we'll draw our bar graph, which will stop at 7. I also will not be using a ruler, so bear with me. 7. All right, so I think it's not bad. 20 to 29. So we'll count the number of people that are between 20 to 29 and draw them in our frequency bar graph. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 people. Right? So Suzumapangu 9, which is the highest number. Right, then we'll go 30 to 39. 1, 2, 3, 4, 5, 4 people. 1, 2, 3, 4 in the 30s. 4 people. 4 is right here. You guys will even have rulers get in your exam. Just make sure everything aligns, ne? I'm not using a ruler, but 4, it's quite not too shabby. 40 to 49, only 3 people. 1, 2, 3. Right, so we'll just go down like this, 2, 3. Right, and then 50 is 1, 2, 3, 4, 5, 6, 7, up to 7. Oh, why is it so bad? It's because it's not true. The number of people, you remember the question that the survey asked us, Itabana, the number of people who use smartphones will be the largest between 50 and 59. That's not true. Even till this very day, I don't think that's true. Maybe that's why the bar graph is not even agreeing for them. 50 to 59 there. So this is how you would do the bar graph. I forgot to write down a title here. Yabona api title here, y-axis iti frequency ne. A title, your x-axis is out here, ages in groups. Because remember I said I grouped them, but if you do them individual, uzobeka 16 uthi 1 16, uzobeka 17 uthi 1 2 3 4 17. Do all of this individually, uzavela uthi ages when, because we group hang. You understand? Cool. I hope it does. Cool. Cool. And now the last question asks us, do the results in the survey prove that Deloitte was correct in their prediction? Remember, what was their prediction? They made a prediction that in 2014, the increase in number of smartphones being used worldwide would be the greatest for people over 55 years old. Right? How many people are even over 55 years old right now? It's 1, 2, 3, 4, 5. When the survey was completed in a mall, right? So now there are different ways in which different people will answer this, as long as it's data, it's information that you get from what was given. So the thing about also ungrouped data is that you can only ask so many people, right? In a case like this, because Otinaena worldwide, do we see how many people would you need to ask to conclude that yay, the prediction is right? You know, maybe the number of people using smartphones would be the greatest over 55 worldwide. You would need to actually conduct the survey worldwide. So how can we make a prediction and go, this is true worldwide, but then we only asked 30 people in a shopping mall, right? So he has to, whoever was investigating this, they have to ask more people. They have to make the survey available worldwide so that they can make that prediction, right? So although even the bar graphs indicate that there were a high number of over 55-year-olds using smartphones, there is not enough data to prove this prediction. It was only conducted in a mall involving 30 people. How can we take a survey that asked 30 people and then we apply it worldwide, right? The sample was too small, right? It would be far more feasible to increase the number of people surveyed to in the millions to get a better idea, Yeah, but there are billion people in the world. Maybe let's just ask, not even billion, over billion people in the world. Let's just ask millions of people. Yeah, but not 30 people to make this prediction. Um, Also a reason here that's stated in the textbook, it says also one would have needed to compare sales in previous years as well. Uyabo. So any reason, I'm not gonna write down the reasons now. Just listen to me, just rewind if you missed my reasoning. And maybe just write down as I speak. So firstly, the survey would have to be available worldwide. We can't ask 30 people, we need to ask millions of people to predict that this is true worldwide. And also you would need to have compared previous sales of people using smartphones. Why does he even make this prediction? How many people bought smartphones in 2013 if this is predicted in 2014? Is it making sense? Also, we would need this is ungrouped data. Remember I said ungrouped data is countable. You can count the number of people. If you count 1 2 3 4 5 6 7 8, we'll get to 30 because we were told that there were 30 people. Maybe also to predict such, we would need to have grouped data, because we would need to have a number so large that it is uncountable. So ungrouped data is not reliable to make such predictions like, oh, 55-year-olds will own smartphones worldwide. It's ungrouped data. It's like 30 people, and how many people in the world? How accurate can it be? Is it making sense? And that is about it.